Good morning, Excellencies, esteemed delegates, distinguished participants, ladies and gentlemen, good afternoon, good morning, as I said, good day to all of those here and connected, and welcome to the launch of the State of Global Water Resources Report 2024 here at the World Meteorological Organization. I am pleased to begin by recognizing here our Secretary General, Professor Celeste Saulo, under whose leadership WMO is hosting today's event and launching this important report. I also extend a warm welcome to His Excellency, Mr. Václav Palek, Ambassador of the Czech Republic, and to His Excellencies, Mr. Sharaf Sheralizoda, Ambassador of Tajikistan. Thank you, Ambassadors. We are honored by your presence and by the engagement of all distinguished participants who have joined us today here and online. The topic of today's meeting is special. Water resources are essential for life on Earth. At least 3 of 4 hazards are water-related, either floods or droughts. Therefore, understanding global water resources is essential for early warnings for all. Water is important for the Earth system approach. This launch event is about joining a conversation at the science policy practice interface, where evidence becomes action and action drives impact. I am very much looking forward to today's keynote presentations and to the presentation of the report. I will say no more. Let me now pass the floor to our Secretary General for her opening reflections.
Thank you very much, Josefina. Excellencies, distinguished delegates, World Meteorological Organization members and partners, colleagues and friends, welcome to the WMO, welcome to our building, welcome to this launch, and thanks for those that are joining online. I thank you for joining us at WMO for the launch of the WMO State of the Global Water Resources 2024 report. This is one of the WMO's flagship reports to meet the growing global demand for science-based evidence to inform decision-making. It is an authoritative, independent, and comprehensive assessment of the world's water resources and the hydrological cycle. I am pleased to say that this report has gained widespread endorsement from WMO members and international partners. As we all know, water brings life. It sustains our societies, our economies, our ecosystems, but it also brings death. The world's water resources are under pressure from growing demand. At the same time, we are seeing more related water hazards. The new WMO report shows quite clear that the water cycle has become increasingly erratic and extreme. It swings between the large and drought, between too much and too little. This has cascading impacts on infrastructure, agriculture, energy, health, and economic activities in general. This report provides insight into freshwater availability. This includes stream flow, reservoirs, lakes, groundwater, soil moisture, snow, and ice. It is based on data contributed by WMO members from hydrological modeling systems and from satellite data. I extend my deepest gratitude to the National Meteorological and Hydrological Services, data centers, researchers, and institutions that provided inputs. You will shortly be given more details about the report. But here I would like to give you some highlights that really strike me. Let us remind ourselves that 2024 was the warmest year on record and was, on the whole, also a dry year. But we also saw many floods. In terms of rivers, only 1/3 of the global river basins had normal conditions in 2024. The rest were either above or below normal. The 6th consecutive year of clear imbalance. So, as a synthesis, we can say that abnormal is the new normal, and that is very difficult to manage. In terms of glaciers, 2024 was the 3rd straight year with widespread glacial loss across all regions. Glaciers lost 450 gigatons of water. This is the equivalent of 180 million Olympic swimming pools. Enough to add 1.8 millimeters to global sea level, increasing the risk of floods for hundreds of millions of people on the coasts. And then in terms of extreme events, the Amazon basin and other parts of South America and South Africa were ripped by severe drought. At the same time, it was very wet in Central, Western, and Eastern Africa, parts of Asia, and Central Europe. El Niño, at the start of 2024, played a role. But scientific evidence also shows that rising temperatures are accompanied by more extremes, both droughts and floods. Unfortunately, water-related hazards continue to cause major devastation this year. The latest examples are the devastating monsoon flooding in Pakistan and Southeast Asia, as well as part of Africa. And unfortunately, we see no end to this trend. The State of the Global Water Resources report is more necessary than ever. It's bigger and better than in previous years. And I'm confident that it will expand further in the years ahead and more partners will contribute. The report highlights the critical need for more investment, international collaboration, improved monitoring, and data sharing. These are core principles which have gained WMO throughout the 75 years of our existence. At WMO, we have always said, and we continue to say, that we cannot manage what we cannot measure. Without data, we risk flying blind. The State of the Global Water Report is one of a suite of products which provide decision makers with the intelligence and insights needed to make informed, forward-looking decisions. It supports vital global initiatives like the Early Warnings for All campaign and the Sustainable Development Goals. To conclude, WMO remains committed to providing the science and the data to inform action to build safer, more resilient communities to protect the health of our economies and our planet. I thank you very much.
Thank you, Professor Saulo. I will now pass the floor to Dr. Stefan Uhlenbruck, Director of Hydrology, Water Resources and Cryosphere here at WMO.
Thank you very much, Josefina. Professor Saulo, Secretary General, Excellencies, Ambassadors, colleagues, friends. It's a pleasure to try to summarize a quite comprehensive report of some 90+ pages with many figures and graphs and statistical details in 10 minutes. But I would like to give you a snapshot presentation with the main results. In the suite of the flagship reports of WMO, this water report tries to cover all the water resources and all the hydrological dynamics we have throughout the year. On this figure, you see a simplified piece of the landscape, and you see there's different water stores. Water is either stored in glaciers, in the snow, in the ice, in reservoirs, in soil moisture, in groundwater, in lakes, etc. Or there are fluxes like precipitation, water from the atmosphere to the land, or river discharge, fluxes in the groundwater or soil moisture, etc. And we try to quantify all that and compare a single year, so in this report, 2024, with a so-called climate normal period. So we took 30 years between 1991 and 2020 and always compared how did 2024 behave compared to the other 30 years. Next slide, please. And as Professor Saulo already said, this report became bigger. It is growing, it became more comprehensive, what we want to say. And we are very happy, particularly in the first graph in the middle at the top. You see the country participation. While in the pilot report we did some 3 years ago, you see now more than 60 countries have been contributing their data. So it's very positive, and also maybe producing these reports is also a way to stimulate data sharing and sharing data with us to be able to make these assessments. Also, you see the number of variables that we are able to analyze, and this year we have first time also data on stream temperature, lake temperature, and first water quality maps as well. So really we're able, because of more data sharing, to analyze the system in a more comprehensive way. Also, the number of stations. Look at the discharge station on the left and the bottom. We have more than 2,700 stations. I come to that in a minute. And in groundwater station, can you imagine IGREC, our colleagues in the Netherlands, were able to assemble data sets from more than 37,000 data groundwater wells around the world. Next slide, please. Too much detail on this graph, but what we wanted to say here is in the following maps that you're going to see, if it's very orange and red, that means very little, either very little snow cover, exceptionally dry rivers, low temperature too warm temperature in the river and the lakes, etc. And if it becomes blue, then it's exceptionally much above normal in its for its parameter. Is it the snow cover or the snow water equivalent, a groundwater level, a flow in a river, a stream discharge, etc. Next slide. Let's start with precipitation. First time, thanks to the cooperation with the German Weather Service, we're able to have a number of precipitation maps also there now. And you see here the average annual precipitation of the year. And you see large part of the world were not normal when it comes to precipitation. So the precipitation in the year 2024 was often below or much below or above or much above the 30 years average. And you see that, and you might want to remember a few areas. Normally, I always look at these maps and look at the area I know or where I'm from, and so then I remember that. And you see that Western Europe got a lot of precipitation, the Sahel in Western Africa also. It was rather dry in South America, parts of South America, Southern Africa. And this precipitation, we also have extreme precipitation, but too much detail for today. The next slide, please. This is translated into stream flow. So the more it rains, the higher the river flow in a very simplified way. It's a bit more complex. But what we see here is all the 2,777, I believe, gauging stations which we could analyze. And every dot shows here at this point in the river, that's the discharge. In Latin America, there's a lot of orange dots in large parts of Brazil and neighboring countries. Western Europe is rather blue and it was very high flow on average with the stream flow. And parts of Africa is variable. But you also see the problem from the in situ measurements, so from the data that the countries were measuring, making us available, only 3% of all data comes from Africa and Asia. Yeah, because data was not available, or countries didn't want to share or couldn't share in time because of whatever reason. And this is the first time where we, in addition to in situ measurements, we also, with precision altimetry, we measured the water level from space, or not me personally, but colleagues in Stuttgart University, and they made estimations, and we were able to fill in data gaps, and we had much more data available because of Earth observation. So it's really fantastic. Nowadays, from space, we can observe the rivers quite well, and that really helps the countries to get a better grips on the water resources availability. Yet now, next slides. This is now the result. The first was in situ measurement, and now you see here an average of the best 12 operational hydrological models. So we get the data from 12 operational hydrological centers in the US, UK, France, Germany, Japan, etc., and they make that available. We make an ensemble, and then we estimate the water resources. And this is the outcome of a model, and of course, you always compare with the in situ measurements. what we see, as Professor Saulo said, in a year that was the hottest on record, and it was never so warm in the last 175 years. Large parts of the year were dominated by the El Nino signal, and we see that the drought, which we had in the previous year in South America, moved a bit north, and less in Argentina, Professor Saulo, but a bit further north, and in a very persistent dry zone in large parts of the Amazon and other river basins. You remember the precipitation in the Sahel? It was exceptionally wet there. And we also see this translation of a lot of rainfall in average high river flows, or in parts of South Asia, India, parts of Pakistan, etc. Also there are high flows. And high flows in Western Europe, and we come to that later again. Next slide, please. Maybe interest of time, I skip this. And next slide, please. Yeah. Here you see just a few examples of other data sets we have. This is the surface temperature of lakes in some 70 lakes around the world. And this is the example during the summer in the Northern Hemisphere in July. You see here that most lakes were much warmer than normal. So the heat in the atmosphere is translated to the heat in the ocean, which is shown in the climate report, is translated into warmer rivers and lakes. Yeah, so that we see in a causal chain, and you really see these distribution patterns. And now you say, well, a bit of warmer lake is maybe not bad if I like swimming and so. But on the other hand, this has tremendous implications on the biosphere, on the aquatic ecosystem, etc. So extremely high temperature in the lake, change the oxygen content in the lake, change the photosynthesis processes, etc., etc. Though this is ecologically quite relevant. Next slide, please. Snow cover. This is the International Year of Glaciers. Therefore, we also give some emphasis on snow and ice. And you see here on the left side the snow water equivalent in March. And you see, can I have one more click, please? You see in many parts it was low in snow. Also, for instance, in Eastern Europe, parts of Asia, you see that also but we also had record high snow in parts of the Russian Federation and in other parts. In Scandinavia, it's interesting, we have in March relatively low snow water equivalent. This is the amount of water stored as snow in March. Why is that interesting? Because a lot of this water melts then in the coming spring and is important for the spring flood, for the flood in the coming months. While we see in the lower figure, this is a snow peak of the snow mass, or the total snow mass which was stored, also again for the Northern Hemisphere. And you see that in northern part of Scandinavia, for instance, we had a lot of high snow peak, but in March, most of it was already gone. And that's what we see in many parts. The snow, even if it's there during this winter season, there is maybe a significant snowpack, but it's melted. It's there for a shorter period of time, and it's melting quicker away. Yeah, skiers might remember. But again, this has major implications on water resources. Glacier, maybe Ambassador Sheryl Zoda might want to speak on that in his intervention, but it is a sad story. And now, since decades, we observe a rapid decline, accelerated decline of global retreat of glaciers. This is summarizing all 270,000 glaciers in the world, and red means that more is melting in the summertime than recharged with snow in the wintertime. And you see here there's a clear negative trend, particularly since the 90s, when the temperature was increasing. Since then, we see a very rapid acceleration of ice melt. And in the next slide, while there's a little bit too much detail, you see that it's the third year in the row where all regions with glaciers have a negative mass balance. Before, we always had a little region, like we circled here in green, parts of Scandinavia. There were a few years where some years were still a bit positive. That means for some reasons, glaciers still increased for 1 year. But now, since 3 years in a row, really all regions of the world have a negative mass balance. So the glaciers are melting away, and they do this very rapidly. Next slide, please. We spoke before about precipitation and discharge. Let me say a few words on extreme events. While on average it was a very warm year, and in many parts it was also very dry. I drew your attention to South America. Large part of the Amazon there's a persistent drought and very dry conditions. We still had very severe flooding in the southern part of Brazil, the Rio Grande del Sud, and that is because of extreme precipitation events. So we see these more erratic behavior, Professor Saulo called it in her intervention before. We see this in many parts. Also, we had in the Sahel more than average rainfall, and maybe you could think, oh, that's maybe good for the farmers. Often the Sahel is a region where, because of unreliable and poor rainfall, there's a lot of issues related to food security. But most of this rainfall that is actually falling in the Sahel, that's what we see in the extreme precipitation statistics, was actually falling as very intense rainfall. So it's not the rainfall that farmer wants, a gradually nice rainfall during the vegetation period. No, it was quite dramatic, intense rainfall during some time, and therefore in Niger and in other places there was severe flooding in the Sahel. Also in Western Europe, Ambassador Balak might want to speak on that. There was severe flooding, and we had about 1/3 of all river basins in Western Europe had flooding. Flooding defined as something which should actually occur only once every 5 years. So in 1 year, 1/3 of all river basin exceeded that threshold. And in the Czechia, in Eastern Europe, it was quite a number of gauging stations that exceeded a threshold of a flood that actually should occur only once every 100 years statistically. Good. Let me round this up. There was a plea for more data and data sharing. These are just examples of the data in situ measurements we have available for soil moisture and water quality. And you see here, there's only very few dots in a few countries, parts of the US or Spain when it comes to soil moisture, etc. So therefore, we heavily depend on remote sensing data and models to be able to make assessments of soil moisture and water quality, because the data is just too little or too short time series, or is not shared by the country. So this is an invitation to help us make this share more data and make our assessments more comprehensive. With this, I would like to close, and a big thank you to all the partners and contributors to this report, who particularly instrumental were the data centers of WMO and other partners, and the global modeling community who runs these 12 operational hydrological models. Without this would be not possible. And I hand over to the master of the ceremony. Thank you.
Thank you, Stefan. And for all of those who want to read the full report, you have a QR code in the slides. You can download it from there. And now let us hear from the country voices. So I will pass the floor to Ambassador Balak. Please, Ambassador.
Thank you very much for the floor, dear Secretary General, Professor Saulo, dear Director Uhlenbrook, Excellencies, ladies, gentlemen, colleagues. It is my great honor to be here today with you at the launch of the WMO State of Global Water Resources 2024 report. The availability of verified and reliable data is of paramount importance, and I therefore would like to praise the growing number of participating countries, the rising volume of data contributions, and the expanding involvement of partner organizations, all of which significantly strengthen the relevance and, most importantly, impact of the report. The Czech Republic has been a consistent contributor to the WMO State of Global Water Resources report, not only by providing data on both surface and groundwater, but also by actively engaging in its review and further development. Our geographic location at the heart of Europe, on the continental divide, often described as a roof of Europe, means that all water from our territory flows outward to neighboring countries. This gives us a clear and special responsibility to share hydrological data openly, as our neighbors. Water management and flood protection rely on understanding the upstream conditions within our borders. Our commitment to hydrology has deep historical roots. This year marks 150 years since the Czech Republic began publishing hydrological yearbooks, with the first edition released in 1875, making it one of the oldest known examples of systematic hydrological observation publication. This long-standing tradition reflects our early recognition of the critical role that data plays in sustainable water management and disaster preparedness. Unfortunately, as was mentioned before, the Czech Republic is also highlighted in the report as one of the countries impacted by the devastating floods in Central Europe last September. But natural disasters, such as the devastating floods mentioned, have taught us how to prevent such disasters and reduce their impacts. That is why the issue of DRR is so natural and close to the Czech Republic, and we widely share our experience and expertise in the field of disaster risk reduction. And that is why we are so keen to share also the data and accumulated knowledge. I will only mention the integration of new technologies and digital tools into DRR, in which we are actively involved also here in Geneva. In closing, let me reaffirm the Czech Republic's strong commitment to the international cooperation in hydrology, disaster risk reduction, data sharing, and digital innovation. By building on our rich historical tradition, by embracing new technologies responsibly, and by staying true to shared values, we can build a more resilient and also water-secured future together. Thank you so much.
Thank you, Ambassador, and thank you for that recognition to the critical role of data and data sharing to reduce disasters. I will now pass the floor to Ambassador of Tajikistan, Ambassador Sherali Soda. You have the floor.
Thank you very much, dear Secretary General, Professor Celeste Saulo, Excellencies, ladies and gentlemen. It is a privilege to be here today at the launch of the State of Global Water Resources 2024 report, and allow me at the outset to extend my warmest thanks to the WMO for convening this timely event and congratulate its leadership. In particular, my dear colleague, Professor Celeste Saulo, for the vision, dedication, and professionalism that have made this flagship report a reality. This report is not merely a compilation of data. It is a vital global public good, providing a clear, evidence-based assessment of the state of freshwater resources worldwide, drawing on the latest science, satellite information, and hydrological data. At a time when climate change is reshaping the foundation of our societies, this report is indispensable for policymakers, scientists, and communities alike. As a mountainous country in Central Asia, we are home to more than 13,000 glaciers and vast high-altitude water reserves accounting for around 60% of the region's water resources. And unfortunately, more than 1,000 of glaciers has been lost in the past decades. These glaciers feed our rivers, sustain agriculture, generate hydropower, and provide drinking water for millions. Yet the report findings are deeply alarming. In 2024 alone, global glaciers lost approximately 450 gigatons of ice, as has been mentioned. This number is not abstract. It represents the disappearance of essential natural water reserves with irreversible consequences for ecosystems, communities, and entire regions. It raises a sobering questions. If these trends continue, where will our societies, our economies, and our ecosystem be in coming decades? This is why Tajikistan has placed glaciers and water at the center of its international agenda. Over the past 2 decades, President of the Republic of Tajikistan, His Excellency Mr. Emomali Rahmon, has initiated global processes at the UN that highlight the centrality of water for sustainable development. This year marks the International Year of Glaciers Preservation, an initiative spearheaded by Tajikistan and endorsed by the UN General Assembly. We see this year not as a symbolic commemoration, but as a call to action, a chance to mobilize governments, scientific institutions, civil society, and young people around the common cause, safeguarding glaciers not only in Tajikistan or Central Asia, but across the world. Earlier this year, Tajikistan hosted an international high-level conference on the International Decade on Glaciers Preservation. International Year of Glacier Preservation. I'm sorry. This brought together more than 2,600 participants from governments, UN agencies, academia, and civil society. The conference produced two important outcome documents: Dushanbe Appeal for Glaciers Preservation and the Dushanbe Outcome Declaration. The appeal is a call from scientists, policymakers, and civil society urging immediate action to halt glaciers loss, protect mountain ecosystem, and strengthen resilience. The outcome declaration is a political message adopted by the governments and partners, recognizing glaciers preservation as a shared global priority, closely linked to climate action, disaster risk reduction, food and energy security, and sustainable development. Together, these documents provide a framework to guide a decade of action for cryospheric science for 2025-2034. Excellencies, the report reminds us that the real challenge is not knowledge, but how we act on it. For Tajikistan, a country of thousands of glaciers, this is not abstract. Without reliable monitoring, we are navigating blind. The report also calls for openness. Rivers do not stop at borders, and neither should information. And it underlines the urgency of adaptation because in our mountains, families already live with floods, droughts, and retreating glaciers. Above all, it tells us that glaciers are not just a regional concern. Their fate is tied to food, energy, ecosystems, and our shared future. This is why Tajikistan has pushed for a concrete action: the International Year of Glaciers Preservation, the Dushanbe Appeal and Outcome Declaration, and now the Decade of Action for Cryospheric Science. These initiatives are our way to turning knowledge, including what we see in this report, into responsibility and cooperation. The report gives us knowledge, and knowledge demands also action. Tajikistan is ready to work with WMO member states and partners to make sure these findings lead to a real change. For us, glaciers are not only ice, as mentioned before. They are water for our rivers, food on our people's tables, and hope for millions of families. Preserving them is not just about the environment. It's about the peace, stability, and prosperity for our future generation. I thank you.
Thank you, Ambassador. And let me remind all that you have the QR code for those online too, and you can download the full report from that QR code. And let me now pass the floor to Dr. Sulagna Mishra, our scientific officer at WMO, who coordinates the report for questions and answers. Thank you.
Thank you, Josefina. Thank you, panelists, Professor Saulo, ambassadors. Excellencies, we will now open the floor for questions. We will also take a few questions and interventions from online audience. A few very quick housekeeping rules. Please keep your interventions and questions short to 2 minutes. And for the online participants, please feel free to include your questions or type your questions into the chat box, and we are going to take them. For our colleagues, you can either raise your hand or you can make your country flag stand up, and we take the interventions. We open the floor now. Russia, please.
Thank you very much for giving me the floor. To be brief, we very much welcome the work of the WMO and this report, and thank you very much for organizing this event. I have more of a technical question. Perhaps could you or somebody elaborate on the technical process of gathering data and gathering information? What does it look like stage by stage? How eventually you put this all together for this report? Thank you.
Thank you. I'll start and maybe you can add. So the process usually starts in the beginning of the year. We send out a letter to all the focal points that we have and the hydrological advisors. A circular letter goes out to the PRs of WMO to request for data, and we exactly specify what kind of data we need. And we collect data until May, so we close the line then. The reason being that countries also need time to collect all the information from the last year, quality check, quality control, and then submit it to WMO. We give different options of sending the data, so either raw data can be shared, but what we actually prefer is also calculated indicators. So in case there is limitations in sharing of data, then indicators can be shared with us, and many countries do that as well. And for the different variables, we collect the data. Some are collected directly by us, and some come to the data centers. So we have GRDC, the Global Runoff Data Center. We have IGRAC that collects data for groundwater. ISMN, the International Soil Moisture Network, does it for soil moisture. Similarly, for water quality, we have a different data center. So usually it comes to the data center, but some of the data also comes to WMO. And we put all this information together in the next month, and we produce a first report. It goes out again to all the focal points who have contributed to have a look at the report and see if the data actually matches what our calculations shows, if it actually matches what they saw on the ground. In the presentation that Dr. Olenbroek showed, we saw there were gaps in situ data. When you have observation, there are parts of the world where there is actually no data available. So in these areas, we particularly asked the member states to look at the modeled data and the remotely sensed data to see if this actually reflects what we saw on ground. So this is also helpful for then the modeling community to improve the models, which can then be used for prediction purposes. And we put all of this together around around end of June. We send out the first draft, and then it goes through a process of peer review where all the member states are involved, experts are involved. This goes on for 2 months, and then we finalize the report, and we usually publish it around beginning of September. Iraq, please.
Sorry, thank you. Have you ever had, I can say, meteorological experience or work and the impact of the climate change on the transborder or international rivers? The sense that the climate change impact on the downstreams is more greater than the upstreams, especially in the Middle East. Thank you very much. Thank you very much for your question. Well, the climate change, which, in layman's speak is often similar to global warming, is what we see in the hydrological cycle. It's accelerating the hydrological cycle. We often see at the global as well as regional and local scales, we see this more erratic behavior, as Professor Saulo called it earlier today. And we see that everywhere. So it's a transboundary basin, particularly challenging, if I understood your question right. But we see often in stationarity of time series. That means what was representative in the past is maybe not representative anymore. So the occurrence of extreme events in many river basins change. So what was, for instance, a very an event which was not very frequent before, which we observed only on average every 100 years, according to our statistics, might now happen in more frequently or more severe. So that's what we see globally. In transboundary, it's particularly challenging if the countries do not collaborate. I think there's multiple studies that demonstrate only if all riparian countries jointly share the data, jointly work towards the sustainable development of their water resources in the whole river basin, then all benefit from it. And there's multiple studies on that. If I understood your question right, in transboundary, it's often the data sharing is one of the challenges, that not all countries make all the data available to the upstream countries, not always to the downstream countries. While we see many river basins where this is done, that all benefit from the end, because you can jointly develop plans and resources and mitigate these effects of climate change or other changes. One point, if I may, what Dr. Mishra also said, we increasingly observe the water cycle dynamics from space, which is exciting. We still need the ground data. We still need to have the surface observations to be able to calibrate and validate the Earth observations, the satellite observations. But we increasingly can actually measure water levels from space, at least for large river basins. So if a country doesn't share, through modern Earth observation technology, we are able to relatively accurately, at least for large river basins, we can observe the water level dynamics and then calculate the stream flow. So the data secrecy, if you might want to call that, at least for large river basin, becomes increasingly obsolete, because we have new technology and tools and models to support countries in that respect.
Thank you. I would just add to that, we also have in WMO a system called HydroSOS, the Hydrological Status and Outlook System, which particularly tries to navigate the issues of data sharing when it comes to transboundary, because what we are also advocating there is sharing of indicators. So if the raw data is not shared, but we can still share indicators which can then collectively make the prediction in the region more accurate and then help all countries in the basin. And the HydroSOS is a global system, so it's helping the other parts of the region also look at what's happening in the area, which are really the hotspots. So to identify which area needs a bit more monitoring and better management than others, and which are the areas that are more affected. So there are multiple options available. So if there is data not readily available or lots of gaps because of which it's not being shared, there are different state-of-the-art technologies that are available and other methods to share the data when the raw one cannot be shared. Thank you. UK, please.
Thank you. On behalf of the United Kingdom, many thanks for this report. We really appreciate it. I'm sorry to hear that abnormal is the new normal, that we get our yearly depressing news when we see this report. But I am encouraged to see the number of countries that are contributing data, and I wanted to see if you could break that down for us a little bit more. How have you succeeded in going from 7 to 60 so quickly in terms of country contributions, and what can be done further to increase that? Thank you.
Thank you. When we started with the pilot report, you saw there was only 70. When it came to the groundwater, it was 0. There was a little bit of hesitation, probably because countries didn't know what is going to be the final product looking like. But already after the first report, we did see an exponential increase. And then since then, the graph is only going up. I think we also see a snowball kind of impact. And of course, countries, when they see the map, they don't want that our country is looking empty in a global map. I think this is one of the major reasons. And when you see the product, you also see how useful it is. And hence you want to be a part of the exercise.
We see reference to this report also in other circles. There was recently a discussion on water investments, and repeatedly countries actually at the G20 preparation meeting, they repeatedly refer to this report because it's useful. It guides you to hotspots of water resources changes, and therefore this evidence base can help to target investments in a better way, more effective, more sustainable. So understanding water resources dynamics can be very helpful to set the right policies and to target effective investments. So therefore they see the value of that, and that is hopefully also a trigger for more countries to share their data. And we understand in some countries it takes longer to validate their data. They even want to share, but they don't feel comfortable because of our strict deadline. On the other hand, we cannot wait too long, otherwise we publish an annual report 2 years later. it's a challenge, and we are there to support with capacity building training as much as we can to speed up that process and make this water resources information available as soon as possible, because it's in the interest of the countries and the upstream and downstream countries, as the colleague from Iraq stressed.
Thank you. Slovenia, please.
Thank you very much for giving me the floor, and allow me to also thank you on behalf of Slovenia for this very comprehensive overview that actually helps us and enables us as well to actually keep the state of our waters under continuous review. And that's exactly what we need. It is very unfortunate to see again and listen again that hydrological cycle is disrupted. We've also seen other reports, other data that you show that are definitely not very encouraging. So I would say that, yeah, the report, on one hand, it gives us these valuable insights, but as well, it encourages us and gives us motivation and invites us as member states as well to improve, to strengthen our water resources management. And this data that we get helps us, to be aligned with the UN's vision on early warning system and sustainable development goals. But equally as this data presented, the part of the report that is also important for us is the policy guidance part. So this then really helps us also in our work, let's say under the UN Water Convention. It also helps us as Slovenia, I can say, doing our work better under the Water Convention as well. So there are numerous actually areas of application of this data, but also the policy guidance. So I do not actually have a question, but allow me just to also express Slovenia's continuous support for the work of WMO. And yeah, we do this all across the sectors. Thank you very much.
Thank you, Slovenia. We are extremely happy to have the support of Slovenia since the beginning of the report. And as you just said, this is a very standardized report where we follow the same process for the entire globe. So having to look at the globe from a bird eye perspective gives a very unbiased opinion of what's happening in different parts. Of course, we have national reports and regional reports, but they probably all follow a different standard, different methodology of calculation. So we are not able to compare when we have these other, let's say, separate, especially distributed reports, but then this brings all of this together and with the latest data. So of course, supporting the UN vision. If Professor Saulo wants to add.
No, maybe if there are no more questions, I don't know if there are any questions online. Yeah, please.
Hi. I'm speaking on behalf of a Swiss NGO called Meeting of Waters, and I have two questions here. I'm also a apprentice and non-expert on hydrological sciences, and my first question is regarding our data sets regarding land use, such as soil moisture and transevaporation. Is there a bridge between data sets and all the comprehensive visualization that we see in the report? Is there a way to link these two to realize that, hey, this precipitation and groundwater evaluations are linked with the forest coverage and the land use decisions that we've made? These are some cause and effects in these data sets and between multiple water resources that we're describing. And the second question I have, and I always have, is regarding our oceans. When we talk about water resources, we kind of exclude oceans immediately because salt water is not resources as water. There are other resources to extract from the oceans, but ocean plays a very major part in meteorological processes, especially regarding precipitation and a lot of the extreme weathers that we see. But the state of oceans is not included in this report. And me personally feel a bit, of course, I'm speaking as an outsider, and if I don't see oceans as part of the water resources, but then it plays a really important role in the hydrological cycle. So my question would rather be, if we were to include oceans in this report and to collaborate with nations collecting data, what parameters and what measurement will we include in this report? Thank you.
Thank you. I can take the first part. And your question on soil moisture and evapotranspiration and how we can establish the connection between them. So in the presentation, of course, we only showed a few results. When you go into the full report, we have specific chapters on all of these variables. So we also show the total terrestrial water storage, which is a combination of everything that you see on the land. So the combination of all freshwater reserves, and soil moisture and evapotranspiration, of course, being very crucial part of the total terrestrial water storage. In the first, one of the first slides that Dr. Uhlenbrook showed, we saw the water cycle, and we put all the components in the cycle in the report. So when we compare the total terrestrial water storage and the influxes and what is happening to the stores, the different buckets, let's put it like that, we can see the red thread. So what is the impact if there is more precipitation? Where do you see that manifesting itself? Do you see a lot more in the river flows, or was it actually flowing into the groundwater, or did you see a lot of evapotranspiration because of the high temperatures and so on? So there are different variables that we have included, and I welcome you to read the full report to have a look, have a deeper understanding of this. Thank you. Maybe Dr. Uhlenbrook can talk about the oceans.
Or a small addition is that the soil moisture measurements we showed in situ measurement, soil moisture is a highly variable variable. You know, if you look at a certain point, you know, it really depends on the very local situation. Where do you measure it? At the end of a hill slope, or in the middle of a hill slope, or at an area of convergence, etc. Furthermore, it varies in depth very rapidly. So one moisture measurement is very difficult to interpret at this global scale for water resources. So therefore, the limited amount of data, we showed that, but we need much more to make useful analysis. Therefore, the modeled soil moisture from these 12 operational models are probably more insightful in terms of average moisture conditions. I'm not saying models are better than ground measurements, but I'm saying that for that scale we are analyzing, modeling is probably a more useful way. And also the land use continuously is updated in the models. The rapid land use changes can reasonably well monitored with Earth observation data nowadays. The oceans, yes, very important. We all agree, but there's only so much we can put in one report. And we appreciate your plea maybe for an Earth systems approach, when I understand it right, where you would like to see all the key systems seen together. And we try to do that, but this report just focuses on freshwater. There is some ocean data, for instance, in the state of climate report when it comes to the ocean temperature, which is escalating from year to year, unfortunately, similar to the air temperature. Yeah, so it would be nice, but it makes us increasingly comprehensive. This is a report that focuses on freshwater resources, but I fully agree on the importance of ocean for the hydrological cycle.
Thank you. In the interest of time, we'll just take one question online. Luna Bharti from Germany asks if the report in the future is also going to cover challenges in meeting global water demand, the over-allocation of existing water supplies and growing urban demand place immense pressure on the water resources. Are we going to look into that as well? Maybe very short, I can add. In a way, in the report, we already included, not exactly saying these are the areas where over extraction is happening, but when we look at the different variables and we see the connections and the and the patterns in them, we can point out what is happening in a way in which area. For example, there are areas in this year's report we have included. Let's say in a certain area, the rainfall was much above normal. The inflow into the reservoirs were also okay, but we see in the reservoir storage, it was much drier. These are conditions when you can actually say that this could have been because of over extraction. This is where, this is what we have already included in the report. But if we are going to include more further details of over extraction and point into the areas, I'm afraid this is a bit out of scope for us at the moment. With this, I would like to give the floor back to our master of the ceremony.
Thank you, Sulana, and thank you all for those interesting questions. For those of you here in the room, there will be coffee and we can continue the conversation outside. For those of you who are online, I hear nearly 200. Thank you. I will now pass the floor to our Secretary General for her closing remarks.
Thank you very much. And thank you very much, Excellencies and colleagues, for the reflections that this report started to build on your minds and on your message back home. I would like to mention a couple of things that for me are quite relevant here. And they appear many times. It's the value of sharing data. We need to action on that. It's not just the willingness. We need to do that. You can see the map. It's up to you. But that brings value. And it's not only about sharing data, where WMO puts a lot of emphasis, but also standardizing how we share that data in a way that we speak a common language. As we are speaking English today, so that we can understand each other, it's important for us that we share data in a way that everyone can drive the same conclusions out of the same data. So that is another message I would like to highlight. Because of this big exercise, we can start to understand what is happening. If we don't understand, we will not be able to manage. And when we say that the new normal is really the abnormal state, that means that our countries, in terms of water, for example, are prepared with dams, with bridges, with roads that were designed for different rivers. That is what we are actually meaning. It has a strong impact on your decision making. And it's also important to share that because you can see how you can collaborate or complement your neighboring country. And that's the value of sharing. So as also you have highlighted, yes, we have bad news to share in terms of some results that we cannot put under the table. We cannot do that. The extremes are increasing. And both ambassadors mentioned that these extremes are not abstract numbers. People are killed because of floods. And in the Amazon example, many people were, 1.2 million people were isolated because they could not navigate one of the biggest rivers in the world. They couldn't. So what? That's my question to all of you. But there are good parts also here, because thanks to sharing data and thanks to sharing understanding and thanks to sharing good practices, we can contribute to a different water management strategy. And also plea and also help those countries that cannot measure to improve their monitoring system. When we say how we really cover the data gap, it's by supporting those that are behind to make sure that they can monitor their rivers, their mountains, there are glaciers. I don't know, but if you go into the details of this report, you will see that the snow cover picture does not cover the southern tip of the world. What happens? This is a common responsibility. It does not cover the southern tip of the world because there is no enough data, and maybe we cannot put all the efforts we need to put to have a global coverage there. So let's look for what we can do. And when I say increase the monitoring capacity, yes, we need to do that. We need to support that countries that are behind to make sure that they can monitor and then that they can keep their monitoring alive. So I would like to thank the partners, the countries, the experts, because this is not only about national meteorological and hydrological services. They are the core part, but we've seen a bunch of institutions in the last slide by Dr. Uhlenbrock. There were many partners that are in the academia and even in the private sector that contribute their data and their knowledge. So that is the good news. We are still able to collaborate and to go beyond our own limits. So I want to share with you my great appreciation for what you are doing, inviting you to do more, if possible, and let's share a big round of applause for this great report. Thank you very much.
We now close this session, and as I said, you're all welcome to coffee outside and to continue the conversation. And to those online, thank you very much for your participation.